Good day. In this class, we want to discuss function of single variable. First of all, I will start with what is a function. Literally, when we say function, the word function arises whenever one quantity depends on one another. Generally, it is a behavior that cuts across all aspects of physical sciences. A behavior such as a population of a place, which is depending on time t, or a circle depending on the radius r, or the cost of milling, which depends on the weight of the envelope or what have you. So when we say a function mathematically, we mean a plane. We mean an xy plane where y is dependent and x is an independent variable. What we mean by this is that the value on the number line here has values which ranges from negative infinity to infinity. So this graph is represented by an equation y equal to f of x, and what it means, what this equation means literally is that we say this y is a function if for any value of x on this number line there corresponds a unique y. So we want to know when there is a value for x, what is y doing, or how does y look like? Okay, so this is what we refer to as a function. An example of such case or of such a behavior is the equation y equal to x squared plus 1. So to know whether this equation is a function, we need to check for each x what is y. If y is unique for each s, then we say this equation is a function. So since there are several values of x on the real number line, it suffices for us to choose a number from the negative side, a number from the middle, which is 0, and a number from the positive. Here, let's choose x to be equal to negative 2. So we want to see when x is negative 2, what is y? So y will be negative 2 squared plus 1. And this is equal to 5. Again, when we choose x to be 0 at the middle, we want to see again what is y doing. Again, we see that y in this case is equal to 1, which is also unique. So thirdly, let us also pick a number from the positive, that is any number from here. So we also see that here x will be equal to, let's use a number, let's say x equal to 3. So again, we want to see what is y doing here. So y will be equal to 3 squared plus 1. here we find out y here is equal to 10. So since for each value of x on this number line, there corresponds a unique y. That is, when we pick an x from the negative side, we have a unique y, which is 5. When we pick a number 0, again, we have a unique y, which is 1. When we pick a number x equal to 3, we also have a unique y, which is equal to 10. So this means that whatever number we pick on this number line, so there is usually a unique y. So since this condition holds for any x, then we'll say this equation is a function. Okay, so we can also see another example. Another example is an equation y squared equal to x plus 1. Again, we want to know whether this equation is a function or not. Before we do that, okay, we'll write this equation as y equal to the square root of x plus 1. Again, since we are dealing with square root here, and this function has to do with a function of real variable, the quantity under the square root must never be negative. And because of this, we can choose some of the value of x for which y will be a real number. Okay, if you do this, it means what is under the square root here must be non-negative. And then from here, we have that this x must be greater than or equal to -1. What we are saying here is that the domain of this equation started from -1 to infinity. So in other words, one can write the domain of this function as d equal to x such that -1 less or equal to x less than infinity. Okay, so this is where the variable y is real number. Okay, so for us to do this, so we are taking, what this means is that we are taking a number, any number from -1 through this line to infinity. Okay, so it means we can pick a number from here, any negative number from between -1 to 0, then from 0 to infinity. So here we want to show that this equation is not a function. So by our definition, it means if you pick an x, that should be a unique y. Otherwise, we'll say such an equation is not a function. So let's check. It's suffice to pick just a number of x to see this. So here, if we pick x to be 0, then we have y to be equal to the square root of 0 plus 1. So here we have square root of 1, and square root of 1 is positive or -1. Here we have seen that when x is 0, there are two values of y. In this case, y is not unique. So by the definition of a function that says For a function, for an equation to be a function, there must be an x which corresponds to a unique y. But here, x equals 0 corresponds to two values of y. And by this we'll say this equation is not a function. So it is not a function. So that is it. The next thing we'd like to talk about is just like we have done here, how do we determine the domain of a function? To determine the domain of a function, it means that was when we say domain of a function, that means the range or a portion where an equation exists. A equation whereby when we pick values for x, okay, we can have a smooth curve across the x from the lower band through to the upper band. So let's see quickly one example on this. So here we want to find the domain and range of a function. So this means we want to find all x for which y is defined. Okay, so for this equation, we'll see that for any x we choose there, y is always defined. And if you have to represent this on the plane this, we'll see that for any x we pick on this number line, that will be y which is defined. So for this reason, the domain of x ranges from negative infinity to infinity, where both negative infinity and positive infinity are not inclusive. So we can write the domain of this function is a set x, where x ranges from negative infinity to infinity. And likewise, the range, this is denoted by r, since we have values for y, for any x, it means the range of the function is a set y which ranges from negative infinity to infinity. So what this means is that the equation y equals to 2x, which is a linear function, has its domain everywhere on the number line. Likewise, it has also the codomain on the entire line. So since the codomain, all the points in the codomain will be mapped, so that will be called the range of that function. Let's see another example of how to find the domain and range of an equation. So let's consider the equation y equal to ln of x plus 1, ln of x plus 1 minus 1. Again, since whatever will be here must be greater than 0, since the ln of 0 is undefined, or is a negative infinity which is undefined, So any term that must be here must be number greater than 0. Okay. So here we'll say that the term x plus 1 must be greater than 0. So here x must be greater than -1. So the domain of this function, the domain D of this function will be equal to the set x, where x start from -1 to infinity. So it must be noted there that this -1 is not part of the interval. So though it is in the boundary, and the range, which is R, the range of this equation, we'll observe that we'll pick any number in this range, whatever number we pick. Okay, when we have that the range